Number theory 8.42. When written in base 3, a positive integer has two terminal zeros. When written in base 4 or base 5, the same integer has one terminal zero. In how many other positive integral bases greater than 1 must the representation of this integer have at least one terminal zero? So since it has two terminal zeros in base 3, that means it's a multiple of 3 squared. And since it has one terminal zero in base 4 and base 5, that means it's a multiple of 4 and 5. So since it's a multiple of 9, 4, and 5, the LCM of that is 180. So it's the number of other bases is the number of bases is the positive divisors of 180. So the number of positive divisors of 180 is equal to 18 because 2 plus 1 times 2 plus 1 times 1 plus 1 is equal to 18. So since it's already 4 bases, base 1, 3, 4, and 5, 18 minus 4 is 14 other bases. AOPS number theory 8.43. A cryptographer devises the following method for encoding positive integers. First, the integer is expressed in base 5. Second, a one-to-one correspondence is established between the digits that appear in the expressions in base 5 and the elements of the set V, W, X, Y, Z. Using this correspondence, the cryptographer finds that 3 consecutive integers in increasing orders are coded VYX, VYZ, VYX, VW, respectively. What is the base 10 expression for the integer coded as XYZ? So this thing is VYX, VYZ, VYX, VW, etc. all the way to VY3, VY4, and VB5, base 5. So since the middle digit changed and they're consecutive, that means Z is equal to 3, X is equal to 4, and W is equal to 0 because from over here it's Y and then the middle digit changes, but they're still consecutive. So that means these two are the last biggest two digits in base 5, and this is the next digit in this other tens. So it's Z equals 3, X equals 4, and W equals 0, which is why it's VY3 in base 5, VY4 in base 5, and VB5 in base 5. So also, since V is equal to Y plus 1, that will also be consecutive because it's consecutive. So base 5 digits that are consecutive, that's not 0, 3, or 4 because it's already used. That means V is equal to 2 and Y is equal to 1. So that means XYZ is equal to 413 in base 5. And if you convert it into base 10, it's equal to 108 in base 10. AOPS number 3 How many integers from 1 to 1992 inclusive have a base 3 representation that does not contain the digit 2? So 1192 is equal to 2 times 3 to the power of 6 plus 2 times 3 to the power of 5 plus 1 times 3 to the power of 3 plus 2 times 3 to the power of 2 plus 1 times 3 to the power of 1, which is equal to this 2201210 base 3. So that means we have to find the largest integer that uses only 0 and 1 less than this number. So that's 1111113. So number 2, so since there's no 2 and 3 in base 3, that means you only use base 2 digits. So if you convert it, this in base 2 is equal to 127.